today we're going to continue looking at complex numbers. We want to be able to write a quotient, meaning we're going to be looking at some dividing in complex form, and also be able to evaluate if square roots are involved of negative numbers and write in complex form again, and to also just simplify I to any power. Recall from last time that I is defined as the square root of a negative, meaning if we were to square both sides, so if we square both sides here, that squaring as square root cancel out, so that I squared is then just equal to -1. Okay, so first one, we want to write this division problem in complex form, meaning only having a real part and an imaginary part. So to accomplish this, what we are going to do is split this up into two different fractions. So if there's only one denominator here, which is, or one term in the denominator, which this one has, we can write this as both these two things we have in the numerator divided by that common denominator. Okay, so now what we're going to do is try to simplify from there. Let's actually start with the one on the right here. If we got 12 divided by 3, that would give us 4. And if we have I divided by I, those should cancel out. And so we just end up with 4, a real number there. In that other one, we have 9. Well, 3 would definitely go into 9 3 times, but we have that I on the bottom. When you're trying to get it into this complex form, you can't have I in the denominator. And so how you accomplish that is to multiply by another I. So what we're going to actually do on this one is we're going to multiply both the top and bottom by an I. As long as we multiply it to the same thing over the same thing, it's going to be equivalent. It's just going to look different. So what we're going to end up with on this one is 9I on top, and on bottom we'd end up with 3I squared. And that might not look more simplified, but it is, because now on the bottom, anytime you have a power on the I, you can change that or simplify it. And remember, I squared is equal to -1, and so now we have 9I over 3 times -1, or that's just going to be -3. And now if we divide, 9 divided by -3 would be -3. And so we'd end up with -3I plus 4. And typically we write that with the real part first, so it'd be 4 minus 3I. So that would be the complex form of this one. Okay, let's check another one here, or try another one here. This next one, now we got both a real and complex part to both top and bottom. So on this one, just trying to split that doesn't work. We can't split it into two different things with two different denominators. Doesn't work in this case. So when you have a complex number in the denominator, what we're going to do on these problems is what's called multiply by the conjugate. And we saw this a little bit in the last video, what a conjugate is. A conjugate is going to be the same stuff. So we're going to put 1 and 4I in here, but we're going to change the symbol. We're going to change it from a negative to a positive. And the reason is, when we multiply that out now, we're going to get that denominator to not have an imaginary part anymore. Now, what happens, though, anything we multiply to the denominator, we also have to multiply that same thing to the numerator. And so what we're going to do here is we're going to have to multiply and FOIL a bunch of stuff out. Okay. So let's start on top. If we multiply that out on top, we're going to have 2 times 1 is 2. Multiplying the outside, we have plus 8I. Multiplying the inside, we have plus 3I. Multiplying the last ones, we have plus 12I squared. Let's do the same thing with the denominator now. 1 times 1 is 1. Multiplying the outside, we have plus 4i, inside minus 4i, and the last ones we have minus 16i squared. With the bottom, we know anytime we multiply a conjugate, I told you that would happen last time, those are always going to cancel out when you do a conjugate. And so our imaginary part of the denominator is going to be gone there. So let's do some more simplifying now. On top, we do have some like terms here. So let's put those together. So we got 2 plus 11i plus, and remember we got I squared here and here. So let's, instead of writing I squared, we know that's equal to -1. So let's times that by a -1. Let's do the same thing on bottom here, times by a -1. And so now we have 2 plus 11i minus 12 on top. On bottom we have 1, -16 times -1 is a positive 16. Now putting those together, the bottom's going to end up being 17. On top we have some like terms here, 2 and -12, so that would be -10. And so now that's almost in that that complex form. The only thing we want to separate now is that common denominator into both those two terms on top. So both these two things, we're going to separate and write that common denominator with it. Now that would be the complex form of this. We got the real part of -10/17, and we got the imaginary part of 11/17i. Just to show you again with a calculator that we can do some of this stuff. If we were to write this one out or do this one on the calculator, one way to do this is to go, if you do math, you can write this one as, you can write this one as a numerator over a denominator. I can remember, oh, maybe it's not math. The way you can do it, shortcut way, is hit alpha, and then this top one here, and we want to use this numerator denominator, this top one here. If you select that, you can type this in as something on top and something on bottom. Just again to show that shortcut, hit the alpha to select this F1 menu, and then you do the top one of numerator over denominator. Now you don't have to worry about parentheses. So let's type in the top as 2 plus 3 imaginary number here. And then let's do the bottom as 1 minus 4 times the imaginary number. And then if you hit enter, oh, sorry, I guess it won't work with this fractional way. We do have to use parentheses here. So parentheses, we can do 2 plus 3 with the imaginary, close that up because that's the whole top, divided by, and then type in the bottom one. 1 minus 4 in the imaginary. Oop, didn't get that second time. All right, close this one up, hit enter. It'll divide it and give you the 2. Now notice this isn't, this is a decimal number plus, and if you scroll over on top there, you can see on yours you should be able to scroll over and see that imaginary part. If you want that as a fraction, hit math fraction, and this should give us to it as a simplified fraction. And of course it's not working when I want it, but I know I've done this one before, and you can, hopefully on your calculator should give that one to you as the fractional answer that we got. Sometimes the calculator does have a hard time approximating, so it's good to be able to check with calculator but know what you're doing without it. All right, how to do these now with square root. So if you got square roots of negatives, we know from last time that those can be changed to I. And so what we want to do here is change this to an I and change this to an I. So this is going to be I square root of 4 and I square root of 36. And they're being times. There's nothing in between, so they're times. I times I is going to be I squared. Both of these two Square roots can be simplified. Square root of 4 is 2, and square root of 36 is 6. Now do some more multiplying here, and we're just about to the answer. I squared is the same as negative 1. 2 times 6 is going to be 12, and so our final answer here is negative 12. So actually multiplying out these two imaginary numbers actually gives us a real number there. With B, we did some of these last time, except they didn't have square roots like this one, but we should be able to do these. We're just thinking our FOIL again, first, outside, inside, last. So if we multiply the first ones, we get 12. If we multiply the outside ones, we got 4 times square root of negative 2. And we know if we got that negative in there, that's really the same as I square root of 2. So how I'm going to write that is we got plus 4I square root of 2. All right, now let's multiply these inside ones. And just like before, I'm going to take that negative out and write that as I squared root of 7. And so we got minus, because there's a negative there, 3 times I squared root of 7. And then multiplying the last ones, we got a negative times a positive, so it's going to be negative. I times I is going to be I squared. And then square root of 7 times square root of 2 is going to be, multiply those together, you get 14. And in this case, there's not a lot of like terms to be had in this one. We do know, though, that the I squared is going to turn into our negative 1, so let's do that. And so if that turns into a negative 1, we got negative and another negative. This is going to turn into positive square root of 14. Okay, so now if we want to write this as a real and imaginary part, we can do it. But our two real parts here can't be added together. 12 and square root of 14, you can't combine that into one number because the one part has this square root. So if we want to keep exact answer, we can't do it. If we'd want to approximate it, we certainly could. But so since those can't be necessarily put together as one number, we're just going to write it as 12 plus square root of 14. That whole thing then is our real part. Our two imaginary parts that have I in is right there. And again, those are not like terms that can be added together because square root of 2 and square root of 7 are different radicals. So what we're going to do is put plus. We're going to put our I for the imaginary part. And then in parentheses, we're going to put what would be left if we wanted that as an exact answer. So we'd have 4 square roots of 2 minus 3 square roots of 7. That together, if you would approximate the imaginary part of that. So this whole part would be our imaginary part. That's how you would write it if it had square roots or stuff that can't be combined. Just write the real and imaginary part in parentheses of what would get added together. All right, next one here, write this in complex form. So first thing, let's write our two square root of negatives there with our I notation. So this would be 2 plus, we'll take that negative out and write it as I. Let's do the same thing on bottom. We got 3 minus I square root of 2. Okay, now before we go further here, that bottom square root can't be simplified. This top one, though, from our work with simplifying square roots, we know that one can be simplified. Square root of 12 is the same as square root of 4 times square root of 3. And so square root of 4 is 2. We could write that as 2 square roots of 3. Let's try to get as simplified as possible here. So this would be 2 plus 2I square root of 3. All right. So this one, if we're going to get it in complex form, we see got complex number on top and bottom. This is another one of those. We're going to have to multiply by the conjugate. Pause the video and see what you think the conjugate should be here and write it out, and then check and see if you're right. Okay, hopefully you've had a chance to check. Here's the conjugate on this one. I always want to do conjugate of the denominator. So it'd be 3 I squared root of 2. Step changes the sign now to plus instead of minus. And whatever that is, you also have to multiply on top then. So this is what we want to multiply by in this one. So go through and do all that multiplying now to get to the answer. FOIL both on top and bottom. So we got 6 plus 2 times that is going to be 2i squared root of 2. Inside ones now, we got plus 6i squared root of 3. Outside ones, we got a 2 outside of that square root. We got I times I, that's going to be I squared. And then multiply the stuff inside the square roots. 3 times 2 would be 6. Do the same thing on bottom. Got 9. Should end up with that. Okay, now just some stuff that we can look at here. I see that our conjugate, we always should have those cancel out because they are the same thing but opposite signs, so those definitely cancel. We also know we can change our I squareds to negative, and so doing that now we have this. Always is good to just kind of simplify a little bit each time. Try not to do too much here at once so you don't miss anything. That I squared on bottom is going to turn to negative, so this will actually turn into plus. And also, I know square root of 4 here will end up being 2, and so I'm going to put plus 2 there. Okay, as far as simplifying this down further, we know on the bottom there now we got 11. Okay, so now to simplify to the answer, we want to split this up now into, that's a common denominator there, split it up into its real part and its imaginary part. So the real part, this stuff doesn't have the I in it. The imaginary part, that's these two terms that have the I in it. So let's split that up. So our real part would be 6 minus 2 square root of 6 over 11. And then plus, and both of these have an I, so let's take the I out here, and then what we'd have left is 2 square roots of 2 plus 6 square roots of 3 over 11 for that. So that would be the imaginary part. Now it's in that complex form. If you want to put parentheses around that, you certainly could too. It wouldn't harm anything to do that. With fractions, you don't necessarily have to. Okay, the last thing we're going to look at is simplifying with powers of I. I've kind of said throughout these videos, anytime there's an exponent on I, it should be able to be simplified. And the key thing on this, again, is that we know I squared is equal to -1. So what we want to do on these problems, try to figure out how many I squares there are going to be. If your power is odd, you're going to see what's the biggest even number that could be within that. So if we have I to the 9th power, what we're going to do is we're going to split that up into the biggest even number that is there, which is 8, and another extra 1 there. We still have 9 I's, but we're going to take out the biggest even one there. Okay, so now what we want to do is try to figure out how many I squareds is that. So we got this 1 I over there, I to the 1st power, but we're going to focus on this I to the 8th power. We're going to see how many I squareds would that be. So if we had I squared, what power should we take that to so we'd end up with 8 of them? 4, because remember when you do power to a power, you multiply. So 2 to the 4th, I squared to the 4th power would be equal to I to the 8th power. Now once you've got that figured out, replace the I squared with -1. I squared is equal to -1. So we're going to replace this I squared here now with -1 to the 4th power times I. And then what would -1 to the 4th power be? Well, if you had -1 times -1 times -1 4 times, what would you get? It should end up being a +1 there. And so the answer to this one would be 1I, or just I would be the answer to that. With calculator, you could check that. If you did I to the 9th power, should give us, again, a calculator sometimes has problems simplifying. If you got 1e to the negative 13th power, that's saying 1 times 10 to the negative 13th power in scientific notation. The calculator's trying to simplify that to 0. Sometimes it has a hard time simplifying. So they're saying the answer is 0 plus I, which would be just I. There's no real part to this. So the calculator did give the same answer there. Okay, let's try one more with odd. Let's say we had I to the 103rd power, for example. What would that be? So let's do the same thing. You would take the biggest part of that that's even, and then take out one I. So this would be I to the 102nd power times another I. Now, how many I squareds would that be? Well, if we take on 102 and divide it by 2, that would be I squared to the 51st power times that additional I. What is I squared the same as again? Negative 1. So what is negative 1 to the 51st power? Well, if we multiply 51 negative 1s, that's going to come out to be negative 1. And so the answer to this one would be negative I. I to the 103rd power is the same as negative I. All right, what about if you got an even one? Even ones are easier because you don't have to take out that additional I. So on this one, just figure out again, how many I squareds is this? That would be 11, because if you took 22 divided by 2, you'd have 11. So that would be negative 1 to the 11th power. If you have negative 1 times itself 11 times, that's going to equal negative 1. And so if you have I to the 22nd power, that's same as negative 1. Okay, just to show you on the calculator again, let's try that one. I to the 22nd power. Again, it's trying to say that it's negative 1 minus, this is a very small number they're trying to approximate to 0. So it's negative 1 plus minus 0I, which would be just negative 1. Let's try one last even one. What if we had, say, I to the 24th power? That would be I squared to the 12th power. I squared is negative 1 to the 12th power. If you have negative 1 times itself 12 times, that's going to come out to be positive 1. And so the answer would be 1. So even powers of I should come out to be real numbers. If you have I to a negative power, it's going to come out to be an imaginary number. Okay, you're going to try some problems out, working again more with these complex numbers.